This spring, students from Magee Elementary School in Wisconsin were working on a class project. The class was learning code, and as part of the lesson, they built a robot and wrote a simple code that was capable of following a line on the floor. At the same time, engineers at Farris Automated Systems, a company that specializes in building custom machine systems, were building an automated guided vehicle that functioned much the same way as the robot in the class project. The AGV was designed by BRP, a company that is known for designing, developing, and manufacturing powersports vehicles. The AGV used sensors to follow lines taped on the floor, used RFID to turn, and had safety failsafes, like a scanner that shut down the vehicle if anyone or anything crossed in its path. Now, it just so happened that Mark Johansen, the president and an engineer at Farris, had a daughter in the class at Magee Elementary. Johansen saw this as an opportunity to teach the students a little bit more about engineering, and coding in particular. It was a chance to show the class a real-world application, so he invited them out to his shop for a field trip, with the added caveat that the students were going to make their own fidget spinners. And they are cool. And it just keeps going. It's the whisper of Fidget. The visit was split up into 4 stations. At the first station, a mechanical engineer explained how he created the model for the fidget spinner in SolidWorks, and while he used a different type of code, it was similar to the code that they were learning about at Magee. At the second station, Johansen discussed how important coding was to Farris, and how it fit into their business. The third station featured the AGV, as well as a machine vision demonstration in which the kids could see the code that was operating the AGV on a laptop. In the final station, the kids learned how a piece of code could turn into what is most possibly the world's most durable fidget spinner. The code was used to cut the parts from an aluminum plate on a Haas VF2 vertical machining center, and then drill a couple of holes. The kids were even allowed to use a small arbor press to push 3 dowels into the spinner and finish what is one of the more interesting giveaways from a field trip that I've ever seen. They made about 55 fidget spinners at Farris that day, and it served as a great example to kids who far too often ask, well, how am I going to use this in the real world? You'll use it all right, if anything, to make the most durable and just cool fidget spinner that I have ever seen. But I'm incapable of doing tricks on. I'm a straight spinner. I'm not a trickster. See? Nope, it's dying. Nope, it's not working. Oh, is that a thing? I'm David Manti. This is IEN Now.